Carissa records the temp in Fahrenheit outside her house during a 24-hour period. She constructed the following function. F of t equals 80 minus 10 cosine pi over 12t when t is between 0 and 24. So this is our trig equations that we just got tested on, right? I'm shifted the midline up 80. I've got an amplitude of 10. The negative is a reflection, so it starts at a valley because it's cosine. And then this is the period change, right? Is the pi over 12 times t. So anyways, after how many hours does the temp reach its max value? And how do we know? It would be after 12 hours, right? Because it's graphed, that's pretty easy to see. How could you figure that out if it wasn't graphed? Well, I told you I knew it started at a valley, right? And so after one full rotation, after one period, we should be back at the valley. And so the peak would be the halfway point between those valleys. So you could do 2 pi divided by b, which is pi over 12. And so there would be 2 pi over 1, fire, times 12 over pi. Pi's cancel. 2 times 12 is 24. You can't see yellow. Change it. 24. So the period is 24 hours, which means if it was at a valley to start with, the halfway point would be the peak, just 12, right? I'm just showing you how to do it if you didn't have the graph. Anyways. 2, the air conditioner is set to run when the outside temp is at or above 75. Use the graph to estimate the time at which the air conditioner turns on. So looking at the graph, at what time do you think the air conditioner turns on?
4 hours.
75 would be right here. It'd be above that line because that line represents 74. Go with that 75, and it does appear to be at about 4 hours. How long will the air conditioner run for? So you need to figure out when's it going to shut off.
16 hours.
It shuts off at 20 hours, right? If you keep going across. So if it ran from t equals 4 to t equals 20, that is a time of 16 hours. You'd subtract 20 minus 4. 16 hours, how do you know? 20 minus 4. You can explain why it's shut off. So this is just using the graph and reasoning. But now let's see if we can solve this problem algebraically. So it says A is 75 degrees above or below the average temp of the day by how many degrees? So what would be the average temperature of the day?
80
How do you know?
is the midpoint.
Thank you. 80 is the average temp. That's where the midline is. So 75 is above. That should be the answer. Sorry. Nope, I'm wrong. 75 should be below. Right? It's below 80, which is the midline. It's below by 5 degrees. Below by 5 degrees. B, if f of t is 75, what is the value of 10 cosine pi over 12t? What we were looking at before here was when it was 75, right? So now the next question is, well, what if it was 80? So, I'm sorry. We're still in 75. I'm so confused. Just ignore me. Just pretend like I don't exist. Y'all do that anyways, all right? Okay, if I look at B, I'm going to have to work it over here. I don't have enough room. 75 equals 10 cosine No, I'm an idiot. I'm an idiot. I'm an idiot. Hold on. Understand. I understand. I get the question. Write down f of t. Right? That's the formula. Okay, now, if f of t is 75, so if this is 75, okay? Then what they're asking is, what does 10 cosine of pi over 12t have to be? This whole term, right? This is one term. What do you know this term has to be? No. Okay, it's an equation, right? Let's don't get too in the weeds here. This is an equation that says 75 equals 80 minus garbage. The garbage has to be 5. If the garbage is 5, I get 75. Yeah? Yeah?
Yes. You ordered that. Wait, where'd you get 5 from?
Because this whole thing has to be true. So if f of t was 75, 75 equals 80 minus garbage. Garbage has to be 5. I understand what they're saying. It took me a minute. So, if the whole thing has to be 5, then what does cosine of pi over 12t have to be? So this part, right? If I know this whole thing has to be 5, it's negative 10 times something. Negative 10 times what gives me negative 5? A half. So this whole thing has to be 10. I'm sorry. This whole thing has to be 5. Are we following? I'm butchering this. The whole thing has to be 5, which means this portion has to be 1/2. Because 1/2 times 10 would give me 5. Right? That's what I found so far. Cosine of pi over 12t has to be 1/2. So now the question really is, like, this looks like garbage, right? It's awful inside there. Let's pretend like it's something. So cosine of what angle is 1/2?
60. Yeah.
60-degree reference angle.
So it'll be 130. Pi over 3.
Okay, pi over 3.
That's what I meant by 130.
I got you. I thought you said 130. I didn't hear 1/3. That's why I was like, I think 130 is one of our angles.
Infinite.
No. Well, I mean, yes, but no, that's not what we're looking for. Because you'll see it says, for which value on the unit circle are we equal to? Okay. This is not the only answer, though.
Well, it's 2 2/3. Pi. That gives me 60.
Yeah, but because I'm in the second quadrant, it's
Oh, yeah,
negative.
Yeah. So it would be, five thirds pi.
5 pi over 3.
Yeah, it'd go 571. So how are there not infinite?
There are.
Oh, that's what she said.
Yeah, I said, yeah.
Oh.
But I mean, these are the two terminal sides. It's those two sides. But then there's also 7 pi over 3, 11 pi over 3, 13 pi over 3, right? I mean, we keep getting all these different answers. So let's go back here to the question. Let's see what it says. For which values of theta on the unit circle is cosine of theta equal to the value you found in part C? How many solutions are there? So there are an infinite amount of solutions, technically, but there are two different terminal sides. Now, because our graph is only one full cycle, right? We're only looking at one period of this. You following what I'm saying? I don't have to keep doing the 7 pi over 3, the 11 pi over 3, because we're only looking at one cycle from 0 to 24, one day. So, these answers is what the question mark needs to be. You follow that? But my question mark is ugly in reality. It's this whole thing. So I need to look at where does this equal pi over 3. I need them to be equal. So what I can do is I can say pi over 12t, I'm going to put t in the numerator, equals pi over 3. You follow what I'm saying? Algebraically, like what I'm doing. I found the answer for an easy, if it was just what angle? But this angle is ugly. So I need this ugly angle to become the thing I want it to be. So I set it equal. And now then I have a proportion, so I can solve for t. I need to know what the actual t is here in this problem. So cross multiply. So I've got 3 pi t equals 12 pi. T is not by itself because it's multiplied by 3 pi, so divide by 3 pi. And so we find t must equal, pi's cancel, 12 divided by 3 is 4. Which says what? After 4 hours, it should be 75 degrees. What did we find graphically? We found that on the graph, right? We went 75 across, but now I've done it without the graph.
If you put 5 pi, we'll use 20.
That's a good guess. Right? So let's do the other one.
Right.
If we plugged in the other answer we need 5 pi over 3. So we could say 5 pi over 3 needs to equal pi times t over 12. Is it okay if I know this one is pretty? I'm just going to use one color. Is that okay? Can you follow that? Here we go. 3 pi t equals 60 pi. Divide by 3 pi. T equals 60 divided by 3. So we've just figured out how we can solve that algebraically for something that you'd had to use a graph before. And I realized I did a bad job of writing that on my iPad, but you could hear me talking. So for those watching at home, here is a picture of the math I did. The pi t over 12, this is what I was calling the ugly part, must be equal to pi over 3. Right, hopefully that makes sense to you. And then same thing here. This is where I started, and then I solved algebraically from there. 5, write an equation that can be used to solve the times t when the temp is 83. What we're supposed to do, I skipped 4, didn't I?
Yeah.
Okay, let's do 4. Use the graph to estimate what times the temperature is 83. So if you look back on that graph, 83, it looks like it's at 7. You agree with that? And 17? I get behind that. So it appears that the answer should be 7 and 17. Right? So we kind of have an idea before we solve it. We should get 7 and 17. Now let's write an equation that could be used to solve for these times. So we would want 83 to be equal to 80 minus 10 cosine of pi t over 12. You see how I just plugged 83 in for f of t, the temp I'm looking for? Now, the last time they did all this solving, like in our heads, but we could do this algebraically, right? Let's isolate our trig function. So what I could do is, why is this trig function not by itself? Well, because being multiplied by negative 10, we're adding 80. Right, this is a positive 80. So I would start by subtracting 80. So 3 equals negative 10. Then I would divide by negative 10. Geeks. Okay. Answering these questions. So if this whole thing need to be true, then what did negative 10 cosine of pi t over 12 need to be? If 83 needs to be equal to 80 minus what? So 80 minus what is 83? Negative 3. So we needed this whole thing to be negative 3. Which means
We're stuck.
10 times what? Right, that's what we had here. We basically had negative 10. So 10 times what needed to be negative 3? So you could see here, if I divided by 10, I found that x needs to be negative 3/10, which is what I found algebraically. Right, using that same logic of thinking through, I just solved it algebraically to get that same value. So yeah, so negative 3 over 10, is that on our unit circle? No. So how could I solve this without the unit circle? Because I don't know if you know this, everything doesn't work out beautifully. If I could go to the unit circle, that's great. And I want to go to the unit circle because I can do it in my head. It makes more sense. But say it doesn't. So let's do this algebraically now. I'm trying to solve for t. I don't know t. T is stuck inside a cosine. You follow? So I'm still trying to isolate t. But it's stuck inside a cosine. So how can I undo a cosine? An inverse cosine. How do you undo addition, subtraction? How do you undo multiplication, division? How do you undo a square root? You square it, right? We do the opposite. The opposite of cosine is inverse cosine. So what I can do then, algebraically, is take an inverse cosine of both sides. The inverse cosine of cosine cancels. That's the whole point. And so I'm left with pi t over 12 equals the inverse cosine of negative 3 over 10. Now I know you guys do this next part differently. If I'm trying to solve for t, why is t not by itself?
They multiplied and multiplied.
Yeah.
It's literally been multiplied by pi
It's being multiplied by pi over 12, so what would you guys do?
Keep trying to.
That's not what you would do. That's what I would do. You're correct. If it's being multiplied by a fraction, I would multiply by the reciprocal. You guys would probably divide by pi over 12 in your calculator.
Oh, yeah, I would.
Yeah, that's what I'm saying. But either way, we're doing the same thing. So I'm going to write it as multiply by 12 over pi. I'm going to do the same thing over here. That's its reciprocal. But again, if you divided by pi over 12 in your calculator, same thing. I just don't like writing that because I hate seeing fractions inside fractions. It drives my brain crazy. So what I really want to know is, what's this garbage simplify to be? Calculator.
Okay, can I use
100%. 100%. That's a calculator question. I would say make sure you're in radians. Radians, not in degrees. And you're going to enter that in. So inverse cosine, I'm just thinking ahead. Inverse cosine is defined for which two quadrants?
First and fourth?
Nope. First and
Second.
first and second. We got to know this. First and second, because first and fourth, cosine's positive in both the first and fourth. All students take calculus. We need positive and negative. Because my argument is negative this time, I expect this angle to be in the second quadrant. That's where cosine is negative. So, like typing this in, I would expect something in the second quadrant. And then it's going to be multiplied by 12 over pi. Somebody done this yet in the calculator? What'd you get?
7.1638402
To have a second? Somebody agree with that? So read it to me. What was it, 7.3 decimals?
164.
And what did we say we thought the answer looked like?
7.
7. So could you get behind this being the answer? It's good enough. Okay, but this was not the only answer. This would be the answer in the second quadrant. Right? So where's the other answer appearing? It would be in the... Okay. Which one? Remember, we need the argument to be negative. So which quadrant is the argument negative for cosine?
Second and third? Oh, sorry.
See how I'm trying to teach you the new stuff, but now that we're stuck on the unit circle that we can't be stuck on because I told you you're going to use it the whole rest of the way. Hey, you got to know this somewhere or another. I don't know how to tell you. Second, third, cosine's negative in the third, negative in the second. So I found the answer in the second quadrant. How did I know this was the second quadrant answer?
Inverse cosine.
It was only defined for the...
First and second.
So if it spit an answer out, this would be the second quadrant answer. Okay. Now, so to find the other one, if you'll think about... there's different ways you can think about it. This is the first way my brain went to. Okay? I know rotating from here to here is normally how much? 180 pi. But it's not this time. In this particular problem, rotating from here to here was 12. Because 24 was the period.
Okay, that makes sense now.
So now, how did I get 7.164? Well, I had to have backed up some amount. So 12 minus something was 7.164. You follow my brain? My brain's all over the place. So now, if I were to solve for x, that's figuring out how much I backed up. 12 minus 7.164 equals x. And so with your calculator, that would be a little bit less than 5, 4.836. Somebody second that? Did y'all try that? I mean, I'm just winging it up here. You think I know the answers? Just the luck I've got any? I do 12 minus 7.164. Is that correct? So that's how much I rotated back. So if the other answer needs to be in the third quadrant, that means I need to rotate that much forward from 12. Follow? 12 plus 4.836, which would be 16.836, which is about 17, which is what we said we thought the other one should be. Is that the only way you could do this? No, but that's the first way my brain thought of right then. All right? You want me to look and see how they do it?
No.
Is that way making enough sense? You guys, I know I'm in right triangle world, and I like rotating on the unit circle. That's just the way my brain. Nothing new on this lesson that we didn't go over yesterday. These are just more simplified because it's already set up for us. And we just need to solve from the get-go. So notice, every answer we're given is all the possible solutions on the given interval from 0 to 2 pi. So everything that could be a solution from 0 to 2 pi, we have to list.
Guys, I cannot let it go without saying good luck to the band. They are competing today in the MPA. They will perform at the Alabama State Concert Performance Assessment in Gadsden. That's where they're going today. So we want to wish them good luck. Thank you.
So for instance, the first one says cosine of what angle is negative radical 2 over 2. So the first thing I would do when I work these is I think, well, what quadrants could this be in? So because the ratio is negative, the only place I can get a negative ratio for cosine is the second and the third quadrants. All students take calculus. So I'm going to have two solutions, one in the second quadrant, one in the third quadrant. Now, cosine is a ratio of the adjacent to the hypotenuse. So the adjacent side to the angles needs to be radical 2. The hypotenuse needs to be radical 2. And so, what is the reference angle for this triangle? They both are 45 degrees. So then the question is, how much did I rotate to get a 45 degree angle in the second quadrant? 135, which is 3 pi over 4 radians. And then the same question, how much do I rotate to get a 45 degree reference angle in the third quadrant? 5 pi over 4. And so those are the two solutions. 3 pi over 4 and 5 pi over 4. Do I need to go over another example?
Go over where the. No, you probably don't have to go and draw triangles. I just told you to.
So a couple of them you're not able to draw a triangle for, right? Because you're going to rotate to an axis. So just remember that. If it doesn't make sense as a ratio, that means it's probably on an axis. Specifically sine, cosine, and that's it. Sine, cosine, secant, cosecant. So that page and the next page are all the same thing. That's what we're going to work on today. So this looks kind of dumb because I had to go to the next slide. But this is the answer to number 2, 3, 4, 5, 6, 7, and 8. Look, they're saying that you can't see 8. Number 8 is pi over 2, 3 pi over 2. I can see it on my iPad when I'm holding it really close to my face, so I figured you guys could see it.
Oh, okay.